for starting, I've talked already too much. I leave the word to Brian. So thank you.
All right, thank you everyone for joining, coming from both near and far and virtually far as well. I'm very excited to present what I've been working on over the last 5+ years, particularly when it pertains to this fun sub area of product service systems and prototyping. Let's start with getting it to work. There we go. So as a society, we are constantly trying to move forward and tackle bigger challenges. And there are certain pressures upon us, sustainability challenges, sustainability challenges, and things that are pressuring us to expand our capabilities and expand our horizons. We look at this example right here of the 100-year colonist spaceship proposal from NASA and DARPA together. And as engineers, which most of us are in this room, we ask ourselves, how would we actually design this? You know, we're talking about something that hasn't existed. We don't know how to make it. We don't know what the problems are going to be. But what we do know is that we must start somewhere. So how do we figure out how to ask the right questions? And understanding that all these things that we make along the way will be things that interact with us as humans. So how do we design something that we don't understand that will constantly be in interaction with us in the future? So quickly, this led me to my primary driving question of my research, which is how do we prototype for questions that we don't know? Because those are the ones that tend to be the most important and the most confounding. So we aim to achieve those. So I'm quickly going to go over the main tracks of exploration that I followed, and then I will circle back and we will get a little more context, just so we all know where we're going to go, what we're going to talk about, and I will refer back to this slide so that everybody can maintain their flow of understanding here. Well, we start with the big question. How should engineers build prototypes for product-rich ecosystems? That never forgetting that humans must be in the loop with the prototyping. So for me, 3 distinct areas emerged as I endeavored on this exploration journey. Particularly, initially, my interest lied in how do you prototype intangible aspects of a product service system? So how do you prototype for intangible aspects of a future solution that doesn't exist yet? How do we get people involved? And my initial direction and insight that I found was utilizing experiential prototyping method from design thinking, and that enables us to bring people in through both physical prototypes and scenarios in order to gain better empathy. And for those of us who aren't big empaths here, we understand sympathy when you can experience the same thing that somebody's experienced because you have. Empathy, on the other hand, is when you haven't experienced that, but you need to be able to share that same feeling and same understanding of the situation itself. So that was what was initially uncovered from the first one. Okay, it's not following me. That's fine. Okay, and then that led me, the results from that led me to the next phase, which was how to support co-creation in a diverse set of stakeholders conducting PSS design, which of course there's a lot of words in there that we haven't gone over yet, but we will. Primarily, this was to understand that a lot of these products and a lot of these complex systems and things that we're going to be building are not something that one particular domain or vein of engineering or computer design or anything can actually solve themselves. All of these challenges will involve multiple different diverse stakeholder groups and also knowledge domains to work together to be able to build and explore these things. So the question was, how can we create something that enables them to share the same vision of the future and also be able to explore it in a meaningful way and have deep discussions about what should be included and what we don't know yet. The third one emerged from the very end, which was after discovering a lot of beneficial aspects of things that were created along the way, how do I then go about recreating this experience from the one primary vein of case study that was used for the first 2/3 or so of the actual research? How do I now take what I've learned from that and generalize it and turn it into something that multiple different people or anybody from any different group can actually use to help better their own design. And the basic fundamental insight from there was that it doesn't have to be complicated. Actually, the simpler you start and the more basic you start at the very beginning, the easier it is for people to explore and expand and exchange meaning and expand what we would later call the design space. So those are the main tracks that we're going to be following. But now we can get into a little bit more of the context stuff. So what I looked at is how do you build prototypes and when do you need a prototype? You need a prototype when you don't know things. So how much prototyping do we need to do when we build a car these days? Maybe there's a lot of things that we know about that. It's essentially going to be a car. The only things that we're uncertain of are going to be, what's going to power it, how big should it be, how fast should it go. But these are all things that we know how to solve. These are not unknown entities that we don't know how to design for. When we look at something a little more complicated, a little more modern, Tesla. Still a car, still has the basic parts and components and functionality that you're going to look for from a car. It takes you from places and it has a power and it gets you there. So, but when we look at the infrastructure required to make that car work and actually enable the transportation aspect, we now see it as something that in academia we call a product service system, which is essentially a combination of products and services working together to satisfy the need of the customer. And in this case, our customer is the gentleman there trying to fill up his Tesla with power. At this point, we went from having just a simple product, which is something we design the product and we know how to design that product, to now we have a product and now we also have an ecosystem and a spread out support structure in order to make that device work. When Tesla came along, as my example for right now, it was a little bit of the chicken and the egg problem. Everybody was concerned with what are we going to build first? Do we build the electric cars or do we build the infrastructure grid to support those? In reality, you sort of have to do both. But as soon as the car came out, and that was the main press release from them, now the more unseen press release and less understood version is that now Tesla will be opening up all this giant network of superchargers that they've been building for their own individual infrastructure to now bring in business from anybody with any other type of car. So along the way, they weren't just building more cars, they were actually building an entire new ecosystem for these cars and all other electric cars to actually operate under. And now we have what's called a product service system from that aspect. Now, those of you who have read the documents understand that I focus very heavily on what we call transformative product service systems. The transformative nomenclature here denotes that we are trying to build things in an idealized version in a way that they haven't been done before. We're trying to make things that haven't existed and get them to work better than they would if we had just simply added services or products to existing models. And so when we get to the transformative product service systems, we end up with a different challenge, which is that there's even more unknowns that exist in there. So if I can now help us all understand where I was going with this, we have a product, car, there are known knowns, things that we know that we need to fix, things that we know how to fix. We get to the product service system, a car, a product that we know with a service system added to it. So there are knowns, but there are still known unknowns, but there are things that we know how to solve, such as what's the fuel going to be? It's essentially where are they going to look like? What is it going to be? But it's not that much different. It's essentially a gas station, but instead of gas, you just have electricity now. So product service system with known unknowns that we can solve for and explore. But when we get out to here, idealized versions of transformative product service systems where we can satisfy customers' needs at such a high degree that it's, but the needs are solved that provide so much value for the actual individual customer and the system that we have value in trying to solve the harder problems. So the whole point of a transformative product service system is that it supplies such a high value solution that's worth the effort to actually investigate how do we prototype and build these things. Okay. And again, knowing that we want to build these products and we know we want to build and drive towards some of these futures, or at least that's what certain aspects of our society want to go towards. So in this instance, this will be sort of the main vein of concept that I was working with, which is construction equipment. The transformative PSS occurring here is that it was going to be entirely autonomous, entirely electric, and 10 times more efficient and have no human errors or human incidents. So how do we go about designing something like that? We know there's going to be people in the mix. Even though it is autonomous, we can't close everything and humans are still going to be in the loop for quite some time to come. So this forces us to ask a fair amount of questions that engineers don't typically know how to answer. We're asking questions about a system and a solution that we don't know in a future scenario that doesn't exist with customers, users that maybe aren't even quite born yet, or at the point where we can ask them questions that we want to get feedback from. Because these types of transformative PSSs, they occur over longer lead times. So we're talking anywhere from 10 to 50 years. So perhaps the people who are going to be operating within this product service system are not of the age to actually ask these questions. So how do we start getting information and asking questions about these systems before people have even gotten to the point where they understand what the problems are going to be? So what I've set out in this work is to show that these types of problems, these highly uncertain, ambiguous problems with many unknown aspects, deserve a specific type of prototype. And that is what I built across the course of my research, is a number of different prototypes and a number of different ways to recreate that. So we will circle back to the first question here, which was how to prototype intangible aspects of future product service systems. Now that we have the context of what a product service system is, and also that we are operating within the construction engineering area, we ventured out over a 9-month period to construct prototype to test out one fundamental feature that was going to be crucial to having an autonomous system where humans are actually operating within that loop as well. So the whole point was trust. Trust is highly important to operational efficiency, especially when you're talking about people and machines working together, and how people build trust is not the same way that people and machines build trust, which is something that's been going on for quite some time. Autonomous cars hit the road. Everybody's first question was, how do I know it's not going to hit me? These are questions that we have to ask ourselves. But whereas cars operate on the road, there are much more rules there, similar rules, but construction sites, closed sites, we can actually do more testing and more experience prototypes. So the case study we worked on was a traditional quarrying site, traditional diesel operated quarrying site, where you can see that as a system of operations here, you have a number of machines that are doing all of their individual tasks here, and they're all powered by diesel. So everything is independent and operates as we are accustomed to seeing. So as an individual who's familiar with these things, you can look at that and say, yeah, all the basic components are there. We don't really need anything else. But if you have a transformative PSS vision and you want it to be electric and autonomous, all of a sudden, more questions pop up, more things that we don't understand and we don't know yet. So particularly when it comes to this case study, these haulers, you see that here there's 1, 2, 6 haulers that are then replacing 2 large dump trucks. So this creates a different logistical problem and different logistical opportunities at the site. And here we see that it's not just different machines that are a different color, although they are a different color and they are a little bit different. You also have to account for the infrastructure, especially around the electric autonomous one, is how do we charge these things? How long do they run for? Where are they going to path to each other? How does this person know that that machine is there and is ready to go? And how does that guy operating that machine know that the machine sees him, is ready, and is going to be able to take the load that he has carried for it? So within this system, we still envision, and that's the vision, is that there are still human beings operating, because there's still some things that are just not of value to automate that humans do on construction sites and out in the world. There's still some things that only we can do and we'll only be able to do for quite some time. So we, over a 9-month period, built a prototype that was a physical prototype that you could wear. And I was going to bring that. Okay, forgot that. So we were exploring how to build trust, and how to build trust meant that we identified visual signals, basic visual signals that can give us simple bits of information, but important bits of information. In order to accomplish what humans typically do with nothing more than eye contact, because we sometimes, mostly hopefully correctly, assume that we come from a similar moral base and that the person that I'm making eye contact with in that vehicle does not want to run me over. So then we don't need to have that much information. We can just simply see them, they see us, we understand, okay, I can walk in front, I can go do whatever I need to near that machine and know that they're not going to hurt me. But if the machine becomes autonomous, all of a sudden, that is a much trickier understanding of what it's going to do. You don't know where that machine's going, whether or not that machine sees you, what it's going to be, what it wants from you, whether you want to interact with it. So we built a basic prototype. The helmet was initially envisioned as augmented reality, but this project took place well before commercial basic HoloLens or commercial augmented reality was available for us to mess with. So we figured, let's do our best here, what we can simulate with LED lights and some bone conduction headphones. And so the unit meant that the individual wore the helmet, the machine wore the indicator, and the human also wore the wrist display. Helmet enabling you to get very simple green and red information, and then slowly pulsating to let you know whether you were safe or not. And then if you needed more information, machine could talk to you through the bone conduction headphones if it wants you to move out of the way. Because what we learned was a lot of the automation, people's initial reaction and initial desire is, well, I haven't been around one, but I would imagine that I want it to stop if I say stop. But if you're running a massive quarry site that has so many vehicles operating and you just have someone going out there and stopping machines because they don't feel safe, it's their prerogative. But at the same point, that's not exactly the optimal outcome for the overall PSS scenario. So instead, we had the machine be able to talk to you and tell you where it was going and what it would like you to do, which was as simple as just messaging you and telling you to maybe move back a little bit so that you could get out of its way. So the challenge here was when we brought this prototype and we wanted to test it with people, most people haven't been around autonomous construction equipment. Not many people have been around large 40-ton to 60-ton vehicles that are moving. Even a 60-ton vehicle moving at 30 kilometers an hour is unsettling if you're within close proximity to that. So getting people to understand the value of this solution was challenging because we didn't have the experiential contextual immersion. So we didn't have the context of being near a vehicle this size. So it was more difficult to get people to understand the potential value of the solution. So that led to the next version of the product, which was only about a year later, which all of a sudden now we have HoloLens. And so we're able to achieve our initial concept of what we wanted to look at. And we were able to upload our basic functionality from all the stuff into augmented reality. But the other challenge, the autonomous haulers, at the time, there was only one or two of them, and you can't really get access to a vehicle that is a one-off prototype that often to test simple but fundamental interactions. These are things that are going to happen constantly on a site, and you want to know how to design them best. But if you don't have access to the real machine, what's the next best thing? So we endeavored on building a scaled down functional model of the actual site. And by doing that, we were able to connect the HoloLens and the individuals to the hauler machines. So through the HoloLens, they were able to see the machine, see the general operations on the scaled down site, and be able to interact with that machine and get it to stop and listen to you. So people could then at least see, what does the system do? How do I interact with that system? How would it feel? It's not quite the same as a giant machine bearing down on you, but at least gives them the understanding of, this is a very different machine. I'm definitely not going to be able to make eye contact with it, but being able to at least have the ability to know where it's going and stop it if I need to was a fundamental feature of that aspect of our design there. So essentially that track led us down to building that scale site at the very end and testing it. This was tested at Innovation Days here on campus. And so we had a rather diverse set of people from different domains and different backgrounds in tech industry up on the hill, coming down and interacting with us and giving us feedback on it. And we captured a fair amount of data, but still mostly qualitative data from listening to them interact with us going over the product. And the overwhelming aspect that we received from them was that they thought the scale site was the most interesting thing. That provided a better understanding of whatever autonomous electric quarry is going to be. And all of a sudden, when they see the machines and the haulers and everything doing their job, all of a sudden it became clear. So that led to my next track of the research, looking into how do we support these different groups of people that are necessary to make these transformative product service systems come together. How do we build something that actually functions as a mediating object or a boundary object? Some of us might consider it simply a prototype, but something that when everybody looks at it, they understand. And for us, that was the scale site. Scale site turned out to be a 5 meter by 5 meter, fully functioning, maybe 1.5 years of my life to build with Amshri here. It was very satisfying at the end of the day once you have your small electric children working perfectly for you. Yeah, it did feel rather paternal sometimes, but anyways, when we built this, it was a very interesting game changer. It wasn't initially meant to be used as a research platform. Volvo, who we were working with on this specific product here, wanted us to build a game for an event, Con Expo, so that they could have people come to their booth and play a game, and then they could talk at them while they played the game or keep them around as much as possible. But being the researchers and engineers that we are, we looked at this and looked at the data from the previous research track and said, you know, this can actually provide a lot more different value than it's being given credit for. So it was constructed, and it was very successful in really bringing people around and getting them to understand all of the concepts of it, both the high level concepts of the system. How do all the parts interact? What is it actually attempting to accomplish? What does it really change if you're going from diesel operations to electric operations and autonomous operations? Because although the machines, you know, they operated fake autonomy, there was some magic at play underneath the linoleum of that site there. But to the onlooker, the person observing the system, it was perceived as autonomous. They didn't know anything else other than that it was just driving and doing what it should do. So from that aspect, we saw that people were able to call it suspend their disbelief. That's the important word there. Suspension of their disbelief of whether or not autonomous electric construction fields were even possible. And so by enabling them to see it working, even at a scaled down version, it gave them the understanding of, okay, I see how it works. And if you can do it at this scale, surprisingly, a lot of people and engineers imagine if you can do it at that scale, it's actually not as hard to do it at a larger scale. So getting them to buy in and have deeper, more meaningful conversations around what the problems are and the interests are, whether you were a stakeholder internal to the project, so wanting to understand how to design it better, or whether you're a potential customer or upstream stakeholder of the system and understanding how you are involved with it and what your part is going to be. And yeah, so we took it on a tour. The scale site went to 4 different large construction global events and served as the primary focal point at these events for bringing in people, for initiating conversations. India, we can see it's Amshri. And the India one was the first international one, I suppose, for me, because the other one was in the US. But anyways, here it was very obvious that the product service system on display through the scale site was far more attention grabbing and far more immersive than anything else that was going on around the rest of that event. Because if you looked around, it's pretty much empty everywhere else, and people are just hanging out and they're asking us questions, and they could be anywhere from customers or interested third-party suppliers. And the one quick, I got time for a very quick story. While we were here, we had the president of the largest coal mining company come and express his interest because he could see it, understand it, and then he wanted to discuss, what the opportunities were and whether or not it could be incorporated into something that won at their minds, which was a mixed bag of feelings to understand that you're building a electric, autonomous, sustainable product service system for potentially a coal mine, but you got to start somewhere, and the big players are good players to start with. And then it went to, well, not then, but it also went to China, 2 events. The 2 events it went to in China were the 2 events that I was not able to attend, but at each of these events, we were able to engage with both all the engineers from Volvo that were with us, and thankfully I had Omtree at that one, so we were able to talk to some of the other folks that were around the site and really gather people's opinions and feedback and observations of, how do they think? What did they think when they saw the site? What did it do for them as far as understanding the overall concept, and which aspects of it were interesting and which aspects of it were confusing, and listening to the conversations that the customers would have with the actual employees from Volvo that were there was probably the richest amount of observable data that we could gather, because listening to the depth of conversations and then talking to the engineers after, who were very clear to tell me that this is different questions than they normally get when they present a video or a poster board or something else that is mostly 2-dimensional. The engagement and the immersion and the depth of the design level conversations they were having with these people was drastically different, and that was very tangible for them. The US was the first one we went to, and it was why we kind of continued to move on with the project in the way that we were. Because here you can see those 2 gentlemen that are playing with the machines are actually president of Volvo AB and Volvo CE, who are sitting, hanging out, playing with the machines, understanding what they do, enjoying themselves. And that led me to, a few other, what do you call it? A few other comments, threads that people would bring up, which is, oh, they're toys, essentially. How do you guys get a job playing with toys? And at first it was, yeah, okay, that's a bit unsettling. You're right. But then when you look at actually the level of feedback and the amount of feedback that people were giving to the toys versus how they were normally perceived to giving feedback to more finished prototypes, that was generally the interesting increase there, is that through what we typically call productive play, people were more interested and more capable and ready to provide feedback on scaled down machines, because they're toys. They don't seem like finished products. So people are more willing to give critical or positive, just generally give more feedback based on the perceived maturity of the project, because they didn't think it was so done that they would be insulting the engineers by telling them things that they didn't like to hear. But instead, when it's at this scale, they can point out anything they want and feel free to tell you whatever is on the top of their head. Whew, okay, so this leads to the midway of the research, although it's technically 2/3 based on our 3 sections there. This is where I transitioned from working with the scale site and understanding what its benefits are, what it could offer, how it offers it, what are the key elements of it, and transitioning into now, how can I provide this same capability for designers or engineers attempting to ask questions about other types of products. So not just construction equipment, quarry things, but how do I enable people, designers and engineers and other groups to work with this type of material and be able to get the same benefits that we saw from the scaled down site. So that, in essence, it was about how do we get people to ask these questions that they don't know how to ask, which is essentially what the scale site was capable of doing. But in order to recreate that, it came with an understanding that the scale site was at a different level of fidelity, and it was at a different phase of the actual cycle of development. That was when there was already an understanding that we were going to use electricity. It was going to be autonomous. It was going to be a quarry site. Some of the machines were already defined. So that was more of in an uncertainty area. So people were understanding that there was more known unknowns that they needed to answer and less unknown unknowns, opportunities to look for. So we thought about how to start earlier than that, where we talked about earlier, the big, large questions, the new transformative PSSs that could be a large 10x, improvement on our current solutions that we have now. So I created a few different workshops in order to explore how do we support designers and engineers to ask these big questions and the questions they don't know how to ask. And it seems kind of silly and cute to look at these very simple scaled down sandbox prototypes, but in reality, these are very, very fundamental for getting people to explore unknown areas quickly and be able to share them. I'll finish with this other part real quick. The abstract prototyping, it happened on purpose. It wasn't exactly something that we told them to do, but by providing a litany of objects ranging from, actual buildable materials, simple things, to bananas and coins and whatever they could use to gather meaning around some aspect of their system, they were conducting abstract prototyping. So the value of the abstract prototyping phase was that banana, that coin, and that grape can all represent something in a system. So a group of designers, a group of engineers can be trying to figure out what it is that they want to work on, whether it's going to space, or whether it's going to the bottom of the sea, or whether it's redefining how we transport energy across the system, across the country. All of these small objects could essentially mean whatever they needed to mean very quickly. So it didn't take a lot of time, it didn't take a lot of energy, and they could all move the objects around. So these small mediating objects that everybody's sitting around at a table and able to change the meaning rather quickly, enabled them to explore the design space rather rapidly. And this is where we talk about something very specific, which is they were able to ask a lot of what if questions, which in the design world and engineer world, we call those generative design questions, because they were exploring an unknown, something that we don't know about whatever the system is that they're looking at. They're able to ask a what if question, which is an abductive form of looking at things, opening up the design space, and then pursuing the ability to take that unknown and identify it as something that they want to look into or don't want to look into. So the teams that did the abstract prototyping were actually, I'll say light years ahead, but based on the amount of data we gathered on them, it was significant. Maybe not statistically significant, as some of us will probably no doubt ask soon, but significant enough from a qualitative perspective that they were much more honed in as a team. So they built consensus as a group of what it is that they wanted to work on, which is the value, what turned out to be the understanding value of the abstract prototyping, is that as a team, you start from nothing, you identify a system, you explore and push the boundaries of that system as much as you want. And then within that boundaries that you've pushed, you can identify a small cluster of things that are in that system that you want to work with. And now what do you do after that? Well, now you need to expose your idea to others, the outside world, because there's only so much that that the team knows to themselves. So that's where the sandbox system prototypes came in, was you take it one level of what we call fidelity, which just means it looks more similar to what it is in simple terms. It looks more representative to what it is in reality. So instead of it being a coin or a grape that's a person, now you have a Bratz doll or a Barbie doll or something that represents the actual entity that's in place. And by building this the sandbox system prototypes, people outside of the team are able to quickly look at their system, recognize what the aspects are, whether it's the transfer of money or the system interactions between the AI and the people and whatever the other elements of their system were. People from the outside can look at it and quickly understand what it is. And experts or peers or other people that might be valuable stakeholders can readily ask them questions and push the boundaries. And that's where even more generative questions came, because as soon as you get external people asking questions, that's when you get fresh perspectives and fresh eyes and expert eyes that can give you more details that you didn't really have within your own team. Whew. And the final aspect of the workshops that we ran was that they were very fast, very simple. It was run at 4 different universities, or three universities. 2 sessions here, one in St. Gallen and one down in Perth. The St. Gallen and Perth ones, I was not directly responsible for running them, but a colleague of ours was, and provided me the data to use, because they were not going to use that data for anything. And so some of them were 16 weeks, some of them were a full semester, some of them were a 4-hour workshop. And so we could see that, if you give them more time to do these same activities, they get better, but maybe not much more marginally better than if you only give them a day or a week to work on them. There was a plateauing point working with these things. Yeah. Okay. Now, if we circle all the way back to where we were talking about knowns, products, cars, things we know, all the way down to the unknown unknowns that we have around transformative PSSs, questions we don't know how to ask because we haven't built them before and nobody else has either. But those are the important questions that we want to ask. So if we then replace those 3 pictures with the storyline from what we just went over. So we have down there, unknown unknowns. In other design terms, we call that ambiguity. Ambiguity is heavily prevalent in what we're calling these product service systems, and particularly transformative product service systems, because they are large, expansive systems, complex, things we don't understand, a mixture of new and old products and services that come together in ways that we can't imagine yet. So high ambiguity. So the solution or proposed opportunity that I found within my work by doing this workshops was that the abstract prototyping was very, very good for handling these early, you don't know what questions are valuable. So it's good to ask a lot of questions. So by enabling them to do very simple prototyping, they were able to ask a lot of questions that could be important, could be not, but at least they got around a clear message and a clear understanding of what it is that they wanted to work on. Then we move a little bit away from the complete unknown unknowns and a little bit more towards known unknowns or unknown knowns, depending on who wants to ask that question. And now you have something that looks like it. So you have identified a system, you have some aspects of it in place, and now you can start asking questions adjacent to what you know. So known unknowns, things about how the system is going to act. You've already identified a lot of the components there and a lot of the actors and a lot of the systems and interactions, but now you need to start to investigate and measure and learn what it is, how are these actually going to come to fruition if we endeavor to actually build this thing completely. And then we can place the, that's delayed. Now we can place the scale site where it very happily sat, which is directly in the, that's weird, directly in the middle in the uncertainty aspect, because there we had an idea of what the machines were, what they were going to do, what they were going to be powered by, and the uncertainties were how are we going to recharge them? How many do we need? How are the people going to interact with them? And those are more things that we could actually research at this point. And by utilizing the scaled down prototype, we're able to explore questions that we couldn't explore in full scale because of time, resource, all the actual limitations that come with doing engineering and design work, which is mostly time and money. So that's where that placed. And then finally, we have what seems like forever ago, my first project, where it's still some unknowns, but a lot of the aspects are already known at this point. So we know the machines, we know the product, we know its people. We generally know what activities they're going to be doing on the site. We know what questions to ask. So we built a physical prototype that enabled them to immerse themselves in the actual context of the construction site. And then we were able to learn from that. So this is the continuum that I've sort of placed everything on, so it remains clear to everybody that essentially, whether you want to look at it in more futurist or foresetting terms, or whether you want to look at it in design terms, or whether you want to look at it in development terms, this is the spectrum that we sit on. And in order to explore those things, we need to figure out how to ask those proper questions about these situations. Now, this is what we want to do when we're doing design and research and engineering. We want to move from ambiguous to known knowns, because that means that we've identified big things, we've measured them, we've tested them, we've put them in a system, we've learned from them, and now we're only down to what size tires and how fast we want it to go. So that means that we've progressed from a lot of unknowns through uncertainty and then into certainty, so that we can actually get to building these things in reality. Because that's typically where most of the prototypes that come into play live. So this would be, if you were to take away one primary thing from the overall research, is that these physical prototypes can be used and have been used, and I have used them, to actually provide these generative design questions, which are what questions are defined that transition us from unknown unknowns to known unknowns. What ifs? How does it? What would it look like? How would it work? So it gets us from a point of things we don't know to a point where we can at least measure it and make marginal impacts on that. So that's the primary thing that I think everybody should be taking away from today. It's important because the literature and academia in general, when it comes to product service system design, particularly, it leans heavily on two-dimensional prototypes. We're talking service blueprints or video, or for the foresetting, they'll use videos, or there's just a lot of two-dimensional pictures and film and things to provoke people, but not to actually immerse them or give them something to hold or look at or understand the moment-by-moment interactions of what's happening in this system. This is how we as people experience the world. The world is not a video that we watch, hopefully, unless somebody's proven something else recently. But it's actually these moment-by-moment interactions. So by having physical prototypes that either can be moved, express what they look like, or actually move on their own and convey the concept of the system themselves, that's what's the uniquely valuable aspect of my work, is that we've shown that we can build physical PSS prototypes, especially when it comes to transformative product service systems. And based on what I found, we should. And this, yeah, exactly. So STAR was where typical prototypes are built in the development cycle. Once we've hit uncertainty, we want to measure and take out risk. So that's what most of the development literature tells us to do. You know, we build products or we build prototypes, particularly to eliminate risk. All the interviews that I did with a fair amount of people from industry, all the engineers and the people on the ground, their experience, they have very valuable tacit knowledge. They've been around these problems and these products and these capabilities of machines and the engineering of them for quite some time. So they have just a tremendous amount of valuable tacit knowledge. But the challenge is that they have been read, taught, learned that you don't really build a physical prototype until it's time to eliminate risk from your system. And so it was my work to then attempt to shift their perception of when and how you can build valuable prototypes. When is it valuable to build a prototype? And my answer was as soon as you possibly can. And it doesn't have to be quick, or it doesn't have to be long or expensive or intensive. It can be cheap and simple, as we've shown, and as the a lot of the research has shown as well, is that it doesn't have to be high fidelity, long, expensive prototyping. It can be quick, short, simple things that actually provide the most valuable when you're trying to answer or trying to figure out what questions to ask about very hard problems. So yeah, the last little things I'd like to say are that, you know, the prototypes, in my perspective and in my area, diverge specifically from where I set out in the design thinking world with experiential prototyping to answer a specific question about trust. And then over time, I learned, well, maybe it's, you know, maybe we build prototypes in these very ambiguous transformative systems about them to ask questions, not answer questions, to figure out what questions to ask. And that's kind of been the fundamental underpinning of most of my work, is how do we get people to ask the right questions or know what questions they can ask or should ask. And then something we didn't really touch on very specifically, but intentional PSS is another way of approaching what we call or what I've referred to as the transformative PSS, which is a shift away from what I won't say the majority, because recently, after I've written all these, PSS design literature has started to incorporate more understanding that you need to be forward-looking, also back-looking, and understanding that you need to meet in the middle and not just use it as a business model platform to add services to a car and call it a product service system. All of a sudden, you have a lease on a car and someone calls it a product service system, which technically, by Tucker's definition, yes, it is. But is it the highest form and the most value you can get out of that vehicle? Probably not. And is it a vehicle that's been designed to be part of a product service system? Probably not. So the intentional PSS design aspect here says that instead of starting from a service or a product and combining some aspects together and calling it a product service system, if you want to have real, meaningful, impactful change and these transformative shifts of society solutions, wipe the slate clean. Doesn't mean you wipe the knowledge clean. You just wipe the solution space clean and start exploring simply and explore that ambiguity. Not try to hide from it, not try to manage it, but utilize this ambiguity as an opportunity to expand your design space beyond what it might normally be limited to. And when you do that, you add a lot of complexity and a lot of ambiguity, but like I've said, it's not bad. We don't need to be afraid of ambiguity anymore. We can utilize it, not just manage it. Yes, and that was not just feasibility prototypes, intentional design space. Yes, so we're not just building prototypes again to answer questions. We are building prototypes to ask questions. We are building prototypes to help us push the boundaries actively of the design space. What should it include? What could it include? What sort of problems should we solve? What are those problems actually made of? How do we look far enough out so that we can have meaningful, long-term transformative impact, and then work it back to understanding how do we understand what that problem is, understand what the opportunities are, understand how to measure that, all up until we can get to our known knowns where we can actually build it and effectively have it just be at a point where it needs optimization. Then this was the final bit here. It's that suspension of disbelief is more of a narrative movie term. So you get people to suspend disbelief of issues so that they can actually continue along and enjoy the narrative of your story. Or if it's horror, you can suspend that maybe that creature doesn't exist like they did in Alien by not showing it for long enough, but it's just something that builds up in the back of your head. So by enabling suspension of disbelief through these physical prototypes, particularly the scale site was the best one for that because it was the most highly functioning prototype. People were able to, skip the initial roadblock in their head of, well, autonomy is not really there, and I don't see Teslas crash. I see reports about them crashing all the time, and this doesn't work, and that probably doesn't work. But when you see it working in front of you, even on a simple closed scaled down site, all of a sudden, your ability to just believe that it's possible opens up new avenues for conversations that you can have that enable a diverse group of stakeholders, engineers, designers to get together and ask questions that they initially didn't know how to ask. So at this point, I'd just like to acknowledge everybody that's been a large part of this journey, although I am 5 minutes over, sorry about that. Particularly all the people in this room have been particularly impactful in my work here. And Jenny, quite an inspiration for allowing me to be a integral part of your guys' operations at the time. Tobias, the whole team here has been very, very helpful. Of course, pretty much none of it would be possible without Omtree and me working together and getting things done. And then finally, obviously, Erica and the one who couldn't be here today, Penny, being very valuable, very patient members of my family that allow me to conduct the things that I need to do to get these things done. So, yeah, funding. It's on the paper. They can say thank you. Yeah, thank you.